Interocitor 1. How many of you folks know what the definition of a balanced signal connection is? Does everybody feel comfortable with that idea?
I'm a little uncomfortable. I know what a balanced signal is, but I don't understand how a balanced signal goes into a single-ended preamp, let's say, and then comes out balanced again.
All right. Well, that was a leading question, obviously. And one of the reasons I bring it up is because there's a lot of misinformation, a lot of misunderstanding about what constitutes a balanced connection. Most people, when they talk about balanced connections, what they're talking about and what they're thinking about is a system that has a matched pair of signals that are opposite phase from one another. And then there is a separate connection that is the system shield / ground. And that's typically what audiophiles think about and what they want to talk about. And this leads to this notion of what is called a fully balanced system or a true balanced system versus something that is sort of an evil, partially balanced system, or something less than fully balanced or true balanced. The fact of the matter is that when we talk about a balanced connection, there's actually only one real definition. And that is that we're talking about, two legs of this signal are going into and out of a piece of equipment. But the definition is that those two sides have to have exactly balanced impedance. That's it. There is no other definition. And in fact, once you achieve that exactly balanced impedance, it doesn't matter if all of the signals on one side or the other side, or a third of it's here and 2/3 of it are here, or an eighth and 7/8. That doesn't matter at all. We think of this as being signals of an exactly equal and opposite phase. And that's a useful definition. That is, in fact, what typically happens in our audio equipment. But in reality, that has nothing to do with the definition of whether it's balanced or not. It's all about matching the impedances on both sides of the circuit. Now, why is that useful? The reason is because when you connect a system like that and send signals down those leads, that it will only respond to the difference between those 2 points. And so anything that is in common between those two wires, those two connections, is canceled out. It will not appear as a signal in the output. And when you can really achieve a very high degree of balance in the impedance of those connections, then you can achieve essentially complete cancellation of what are called common mode signals. And again, the reason that that is useful is because there is a tendency for the cables to act as antennas and pick up noise and radio frequency interference and various kinds of contamination along the way. And that appears as electromagnetic radiation typically, or one sort or another, that can create a spurious noise signal in the cable. And that, because the cables are designed typically as symmetrical twisted pairs or some variation on that theme, when the noise signals cross that wire and create a noise voltage within that wire, it's what's called common mode. It's the same thing on both of those leads. And so when you get to the receiving end, the noise signals are common at both of the inputs, and therefore they cancel. They're not amplified. They don't show up as an output signal. That's why balanced systems are useful. That's why they exist in the first place. I happen to be a very strong advocate of balanced systems. I think it's a very useful technique and solves a variety of problems, typically having to do with noise and ground interaction problems. But it's a useful tool, I believe, and I think, well, I personally will continue to design equipment that uses balanced connections, and I realize that the majority of the equipment we deal with is still, largely unbalanced connection type systems, but I am a big believer in the superiority of balance, largely for practical reasons, not so much for performance. It's very clear that you don't have to have balanced connections to get very good performance, but I think they do solve a wide variety of problems in connecting systems in a noise-free way and eliminating a lot of the kinds of noise problems that we run into commonly when we're connecting unbalanced systems. So just food for thought about balanced operation. And with that thought, I think we're going to get to music, but first I would like to entertain any questions that you might have. Yes, sir.
Did I read that you were using still points internally on it?
What I'm using, I'm using some technology from still points that they've actually made standoffs that have their technology in the standoff. And this is a mechanical isolation system that's, I haven't seen the details of the guts of it, but it's, they make a variety of products now, starting with their external feet that include this technology. And it's a system that's minimizing the surface area of the connection on two sides of a mechanical system. And they have miniaturized it and put it into the standoffs. And I was quite surprised when I put it in the preamp and power supply. It made a very clear across-the-board improvement in performance, and I really liked it. So now I include it as standard in the VRE-1C and the previous B model. They're still points, as you may know, they make a variety of products, separate feet and rack systems, and quite a wide variety of products that incorporate this technology one way or another. But yes, it is incorporated in the design of the preamp and its power supply. Thank you. Anyone else? Yes, sir.
Is there a statement, a power amplifier coming behind it?
I certainly hope so. I've been wanting to get to that for quite some time, been thinking about it a long time. And so, yeah, I really want to get that done. It's been a little bit difficult. I've been focusing my energies on building and selling the preamplifier, promoting that, getting sales moving ahead with that. It's been a difficult time economically, as we all know. And even this part of the high end, which has sort of traditionally in the past been a little insulated from economic, downturns, well, we're all feeling the pinch this time. And it's an expensive piece of equipment. Let's face it. This thing is $16,950 is the list price. So it's it's going to take someone that's got a lot of disposable income to put that in their system. I've been struggling a little bit with that, and trying to make some headway in sales there before I get moved along to the amplifier, but I really want to do it very soon.
So is the amplifier in your head on paper?
I've been making amplifiers for quite a long time, and a lot of the ideas, things I've been thinking about have shown up in the rebuilds that I've done of my earlier products for SMc Audio. But when I start from a clean sheet of paper, so to speak, I have a number of ideas for new ways of building an amplifier that I'm looking forward to putting into practice. I've been thinking about them for a long time, and I have worked with some of them, but not all of them. So I'm looking forward to a truly new amplifier product in the near future.